11th. So the last time we met, we were talking about these items here about flow resimulation, and we're talking about resimulation rate and burst sizes and token bucket refill size, things like that. And then we broke for the holidays. So that's where we left off. And I guess to reiterate, the goal of behavioral model is to basically, VNet to VNet and be able to code the feature and run the test successfully in BMV2 and pass every time. That would be, the goal of behavioral model. And I would say maybe we were 65% of the way there, 70% of the way there, would you say, Chris, before we had to start filing bugs?
Yeah, I'm not sure what percent we are, but there's certain gaps, like in the stateful processing, primarily.
Yeah, and then Andy was kind enough to write up a gap document between BMV2 and P4 DPDK, which I have on the GitHub. So that's where we landed there. And Mayapan was nice enough to go ahead and write a couple fixes for us. So that's where we landed over the last year. And then, Andy, did you say you had something you wanted to fill us in on? Was that about the ACL piece, or what piece was that you were talking about?
It's so Ashutosh was asking about the status of compiling the dash P4 code that's checked into the public repo on P4 DPDK. And in the past, so I've just refreshed and sent a link. You probably already have it in earlier notes, but there's a dash blocker tag that I've created on the public P4C repo where P4 DPDK code is kept, which I use that tag to mark any issues that I think are stopping open source P4 DPDK from being a good dash P4 compile target. And
yeah, that's this dash blocker tag here, right?
A month ago, there were 2 issues on that list. And since last month, Usha Gupta at Intel fixed one of them.
And what was her name again?
Usha.
Yeah.
Oh, Usha. I remember Usha. Yeah. Okay.
So I haven't fully verified or tested out in a thorough way that the fix is good, but I think it is good. It's certainly a change. Basically, there were issues where if you defined a header with bit fields that were not multiples of 8 bits long, which is pretty common in header definitions, like an IPv4 version is 4 bits and header length is 4 bits. You usually define those as 2 separate bit 4 fields in a header. The P4 DPDK implementation was swapping those effectively in the wire order of bits. So that was a definite bug that had been around for a while. So that one, I believe, is fixed. That wasn't dash specific. That was just, a bug in the implementation that was pretty widely applicable. The remaining issue that's got the dash blocker tag is one where the current dash P4 code uses arithmetic operations on 128-bit IPv6 addresses. And at the moment, the P4 DPDK implementation only supports arithmetic operations up to 64-bit wide operands. And so the people at Intel who've worked on P4 DPDK know about this limitation, and I've told them why it'd be good to generalize it. And that's the one remaining open issue that has the dash blocker tag is please support arithmetic on 128-bit wide operands.
Yeah. And Ashutosh, you're tagged in this one.
Yeah, so I was trying to compile the same program and I got the same error, and I was asking Andy if this is the only error he saw. And I think he verified that, yeah, that's the only error. So I did have a conversation with the P4C DPDK target team, which has to support add the support for 128-bit operation. So we just started talking. So
Nice.
I'll get back to the scene. Yeah. Right now, they only support 64-bit operations because this written for a 64-bit CPU, so they don't really have support for anything more than 128 bits. So it's not the compiler, is the target which has the limitation. And I think once the target's limitation is fixed, then the compiler can probably add whatever is necessary for the target. So it's like 2 different components need to be fixed for 128-bit support. Yeah.
And if they do decide to generalize the target, I have mentioned to Christian, I think in the issue that I linked as well. I mean, it's not hard to do 128-bit plus and minus operations, arithmetic operations, but the current -P4 code doesn't need those. It just needs bitwise OR and OR, which is maybe slightly simpler if they want to break it up into smaller bits of work.
Yeah, I would try to convince him to just add support for AND and OR, bitwise AND and OR, and the other things like add subtraction, addition, shift. I don't think we even need shift also.
The current -P4 code doesn't, yeah.
Yeah, so so I think I'm just trying to convince him to see if we can get that support for this.
Bitwise AND and OR would be enough for now.
Yeah, just AND and OR, yeah. Bitwise AND and bitwise OR, yeah.
Thank you. That's a big one. That's a lot of progress there. Thank you so much.
No problem.
And I will just warn you, the dash blockers are ones that I am aware of and know that they're stopping progress.
Yeah.
Once it's the peeling the onion kind of thing, if this one gets fixed, we might discover something else. But
well, of course.
Yeah.
Yeah, that's what the development's all about. So
as you realize with some experience, that's peeling the onion is common, and it does sometimes make you cry.
yeah, totally. After just over 2 years, totally. So did anyone have something they wanted to bring forward first?
Well, just on the same topic, Andy, do you know, we've been waiting for this aspect to be solved for a while, but I'm wondering if there'd be any benefit to somehow circumventing this shortcoming for the time being, because we may not rely on it for running certain types of tests. Like, is there a way for us to start actually testing the software implementation and just accept that there might be some slight, non-conformance?
You're saying somehow work around this existing dash blocker for DPDK?
Yeah, like, can we actually still use the pipeline and pass a number of tests?
I believe if you avoid IPv6 packets and configurations, we could if-def out a few lines of the -P4 code and it should compile on P4 DPDK.
Yeah, we could always put conditionals around certain PTF tests. Right?
Yeah, we could add an enable IPv6 if-def or something and put that around a bunch of P4 code.
Yeah, I'm wondering if does anyone else have any opinion on that? Would that be worth pursuing?
And also, it's only for the service tunnel, right? That bitwise AND and bitwise OR is only needed for service tunnel. I don't think we need it for VNet to VNet scenarios. So,
that might be.
VNet is not there. Yeah, it's service tunnel private link.
Yeah, so we should be able to run even the IPv6 VNet to VNet. As long as the LPM support is there, which I talked to Christian, he said that we do support IPv6 LPM. So, but I don't know if anybody has tested it.
Another thing. Oh, please, Andy.
Oh, sorry. I was just saying I have not tested IPv6 LPM on P4 DPDK.
Okay. So we should be able to test ideally all the VNet to VNet scenarios, even with IPv6, by just commenting out that service tunnel. There's a function, right, which has this bitwise AND and OR operation. And if we can just if-type it out, we might be able to test it.
And another thing I'm thinking, like one of the things BMV2 provides is the custom extension, so we can actually implement like extend function. Is that like P4 DPDK also support? The reason is that we for example, like Psi, there are some like events we need to emit like whenever something happens. So those things are right now not really in BM, in Dash pipeline right now. But if we need to model that, then it will very likely be like the extern function, for example, emit ENI events or whatever. So those things, is there a way like P4 DPDK can do?
When you say events, you mean, for example, you're processing some data packet and you reach some condition that says, I want to send a small message to the control plane to notify it that it needs to do something?
Yeah, like in the Psi, there is like, for example, like the site switch, there is a site switch events. So like, for example, if the route changes or whatever, I just take a random example, not Dash related. it will just send, hey, FTP changed. There is update on that. So yeah, so those events are mostly like that.
And they're detected while processing a data packet in the data plane.
Yeah, they're detected while processing the data packet.
So P4 implementations often support two ways of doing that. One is called a digest extern, that just you collect together some data and call the digest production function, and it sends a message to the control plane, which should then do something appropriate with it. Another is to clone a packet and modify the clone and send that to the control plane. And I believe I can put it on my list of to-do to double check whether I know that BMV2 supports both of those today.
Yeah, BMV2 has a clone. Yeah,
it has both clone and digest implementations. I mean, they're not wildly different. The main difference is some hardware targets will do more batching on digest messages because they're small. You can like batch together hundreds of, dozens of them into one larger control plane message for efficiency. I don't know whether P4 DPDK supports clone and digest messages yet, but I can put it on a list of things for me to check before next meeting.
I see. Sounds perfect. Thank you.
Sure.
Yeah, if you look at me randomly scrolling around, this is where we wrote down what we knew about the gaps. And I don't think we have that listed here.
That wasn't in the -P4 code at the time I wrote this. So, but if we add it, then it could become a blocker.
Also, I didn't see like the list here. So is the echo list already supported in P4 DPDK?
The list that I was referring to of dash blockers is that link that's in that gaps in P4 DPDK section. That there's a link.
This one here?
Yeah, that's the link to the dash blocker tag.
I think in the range list, you think of the match type riff, the match list of ranges.
Yeah, like list ranges. Because I'm not seeing them in
neither. So it's not mentioned. It's mentioned up at the top of this article, which is I believe if you go up a little bit more, Christina.
Oh yeah. In all P4 implementations, yes, that makes sense.
None of them have.
That makes sense. Yep.
And my recommendation for reference model testing would be that some part of the dash control plane should do the cross producting or multiplying out so that there are no lists in the data plane anymore, would be my recommendation. That works for scale, a certain level of scale, but no further. But for small enough configurations, that would be perfectly functionally correct.
So, Andy, if let's say we were to agree tentatively to start getting some tests running in Dash on the P4 DPDK, what would be the next step? Let's say we agree, okay, we'll bypass this service tunnel, use case and focus on use case of do work. What would be the next step? You initially compiled everything. We would need to figure out how to spin up an instance of it, right? And connect it to the test harness.
Yes.
What's involved in spinning up an instance of it? We actually haven't tried that in the Dash project yet.
So my experience using P4 DPDK at this point consists of I wrote up some instructions, some steps that I've followed in my P4 guide repo of one way to do it, which is to build a P4 DPDK Docker image. And inside that Docker image, it builds the P4 DPDK data plane, the software switch, as a user process, and some other.
Is that in here, Andy?
It's in my P4 guide repo. I can send a link to it in the chat.
Oh, okay. So it's not this one. Okay.
It takes about an hour or two to build that Docker image, I think, if I remember correctly. And then once you do it, there's some steps that basically you can take some P4 code, compile it using the P4C DPDK, copy the spec file and some other produced files into that container, and then run a few more commands to start up the P4 DPDK software switch and run it inside that container. That's what I've done so far before. I believe there are instructions that it should work without having to do it inside of a container, if that's preferable. But if you can run it inside of a container, then that.
What would be preferable, and it's a bit self-serving and lazy, but would be to be able to just pull off of Docker Hub a pre-built container that has some release of P4 DPDK already running,
Got it.
like we do with BMV2. I actually don't have to build it. I just pull it off of
And
Docker
is there any particular version or distribution of Linux that you'd prefer to run that container on?
Well, I guess Ubuntu 2004 it would be consistent with the rest of the Dash infra, although people have got it working for Debian too.
Okay. Yeah, so I've gotten the container built and running on Ubuntu 2004, so that's a good match already. And so if somebody were to, I mean, I wouldn't mind publishing such a container periodically, like, you know, every 6 months or something like that, or maybe more often if there's active bug fixes.
If there's a good recipe to do it, then what I've done in Dash, even for the BMV2, because I actually take and customize the standard distro by trimming off backends. We don't need that kind of thing. We could have the complete recipe, the Docker file and everything, and make files, whatever it takes, to build DPDK from source if we need to, if there's no standard published one, and then we push it to the Azure Container Registry and only rebuild it when the recipe changes.
Yep.
And then everyone who does, you know, Dash builds can just pull it instantly and run it. We can run it in the CI, you know, Azure cloud, but I guess there's only 2 cores available, and I don't know if that's going to run in the Azure instances we have. You know, we might come up against some CI/CD limitations without, let's say, getting more resource through Microsoft, which, you know, they've offered. Just haven't gone down that route yet, but we could get bigger instances.
If you're talking a few dozen packets and reasonably small configurations, I doubt 1 core would be a limitation for a while.
Well, the problem is it depends what else is using cores. Like the XCC traffic generator, I think the receive side has a dedicated pinned core, and then all the rest of the Dash pipeline and test infra runs in the other core. And it's, you know, low duty cycle. So we might have to make some trade-offs to what can run at the same time. Do you know if the P4 DPDK needs a dedicated core, or can it share core?
I do not know. I know that when I have run it myself, I've done it in a VirtualBox VM running a 2004, running that container with 4 vCPUs, and never noticed, you know, for a handful of packets, I've never noticed that being a problem.
Yeah. Yeah, it might not be. You never might run into a performance issue, but if a core has to be dedicated, then you'd find out when you only had 2.
It's not obvious to me that it needs a dedicated core, but I don't have to check.
Okay.
And I noticed that Ashutosh sent a link to my published instructions on building a Ubuntu 2004 container that is the correct link.
Oh, nice.
Yeah, that's the one I tried to come, and so at least I can verify that the instructions work. So.
Yeah, I check them every 6 months they do another IBDK 23 or 24.01 or .07 release, and I haven't checked it for 24.01 yet, but soon I'll do that.
Thank you.
They worked for about a year.
Awesome.
I think what would probably make sense would be there's a P4 DPDK directory, you know, in Dash. We could put the make files and all the recipe for building this could be in there, or even in the main one. But maybe we start experimenting with building it. Maybe I can take a crack at playing with this recipe, seeing how it goes for me too. And maybe we can start taking some
build instructions are actually shorter than the how to use or run instructions right now. So it's the build instructions are the simpler part.
Good. Is anyone else on this call interested in this as well? I mean, is this of interest to the general group to have a potentially alternative implementation that might be quite a bit more performant long term? And, you know, we will also have the benefit of P&A architecture, right? So we could have add-on miss and that kind of thing. Is that correct, Andy?
I have tested at a very small handful of packets with add-on miss, and it does seem to work.
Seems to work.
Yeah, I haven't.
So for the add-on miss, I think right now, are we looking at like using in the flow miss case, like when flow is missing, like add a flow entry?
whatever the dash P4 code uses it for now, I think it's, it does
see.
match lookup on a tuple. If it misses, then it goes through.
I see.
So,
So,
at least.
So basically, I think for the flow insertion, we'll very likely. So what we are trying to right now, we're trying to do the experiment. Is that we are trying to add another like application that's running aside of the pipeline. So the reason the flow insertion may not be able to use like add-on miss semantics is because say there is a flow miss and add-on miss is then okay, if this table has a flow, this table is missing, then I'm going to insert an entry into this table, so the key is not going to be changed. We provide like actions and the parameters, so it will be like inserted back to this table. So however, in the dash, what happens is that we will have to go through the entire pipeline, like the rest of all the tables, and in the end of the pipeline, there will be a routing type being published. At that time, we will decide like what kind of flow we can insert back into the flow table, which is actually lives in the front of the pipeline. So that's why for the flow insertion, very likely we'll need what we are doing the experiment right now is that we are trying to create a DPDK-ish type ish program, right? So it has an interface and it attaches to the BMV2 or whichever the pipeline is. So the packet goes through the pipeline, then goes into the application. The application then calls certain APIs, then insert a flow entry back. So that will improve the add-on miss case that required by Dash, but it's not like probably not like plain add-on miss that provided by PNA. Does that make sense?
Well, I understand your explanation, but I don't understand the motivation. Are we or are we not as expecting the data plane to add flow entries on the fly in the data plane, regardless of implementation, right? Black box. Are we?
By data plane, do you mean like
no control plane messages,
real hardwares? Oh yeah.
Yeah, no
this
control
one
plane
is
messages. Right? I mean,
you
have a million connections
this
per
is
second.
part of the data plane. Yes, then the application is just like part of the data plane. You can consider that application as a CPS path.
Okay, let me try to ask this a different way.
Yeah.
Dash implementation, hardware, software, black box. If it's correct Dash implementation, it's going to be adding flows in the data plane without control plane messages going up to a controller, right? Sonic or SDN, right? It's all on the fly, self-contained.
Yes.
Okay, so then now we talk about different implementations in the Dash working group.
No.
Sorry.
Yeah, I'm not talking about. I'm not talking about different implementations. This is not a control plane component.
Yeah. Okay. Let me finish asking.
Yeah.
I think what I'm saying is that
the confusion. This is not a control plane. This is not like Sonic or whatever, like SWSS. So, yes, those things. Yeah.
So I think what you described earlier with this side application was an experimental implementation of doing this using BMV2 and some other tricks, right? You're kind of experimenting with ways of emulating this add-on miss with BMV2. Is that what I heard?
Yes, kinda. Yeah. Not really BMV2. I think it just like don't really limit to the implementation. Say if it is P4 DPDK, then as long as we have a way to forward the packet to there, should be okay.
So is it not desirable?
Like a DPDK application, right? It's like an application which is the
which process the packets,
which is like part of data plane technically. It's not part of the control plane.
Is it not a desirable goal then if we had a fully working P4 DPDK or even partially working, we sidestep this logical OR feature. If we had a good working P4 DPK implementation that did add-on miss, that would be good, right?
So the thing for the add-on miss is that if you definitely look at the PNA, right? So in the PNA, the add-on miss semantics is that if a table entry is missing, right, a table is getting hit, but a table entry is getting missing, it will we can specify a handler. Then handler inserts an entry back to this specific table without specifying the key, but only specifying what action parameters, or what actions and action parameters we need to process the following rest of the packet. Oh, sorry, subsequent of the packets. If you look at the dash, is then okay, we have a contract table in the beginning, right? So the contract table is missing. Now we need to add an entry to the contract table. However, the contract table cannot make the decision by its own. It has to go through the routing, the mapping, everything else to say, okay, what kind of the flows we need to add in the contract table. That means that the once make the decision, the table can make the decision is not going to be the contract table, but maybe it's the CAPM mapping table or whichever the later table is. So that table needs to add an entry to the contract table, which is PNA doesn't support.
I see.
So
I see.
One workaround or one style of implementation that you can write PNA style P4 code for would be, we have a contract table where in P4 code where early we look up the contract table, and if it misses, we say don't add on miss because we don't know what to install yet. Just look it up without add on miss and tell me whether you got a hit or miss. If it's a miss, if it's a hit, then we use the result and we have a very short data plane. But if it misses, then we say, oh, there's a big chunk of P4 code. You need to access maybe 10 tables to figure out what the right flow behavior is for that flow. And then at the end of that, you access the contract table again. And this time you say, if you miss, install this rule. So it'd be 2 accesses to the contract table if you miss the first time, where the second one actually installs the rule in the data plane. If that
That's interesting.
I don't even know if that is allowed, because I remember like in the P4 like control block, every single table can only access once. If we access
many implementations only allow you to access a P4 table once per pass. PNA allows you to recirculate packets. Even if a PNA implementation had a limitation that you can only access a table at most once per pass, you can recirculate packets and then you get another go at all the tables if you want.
Recirculate is usually not very good thing though.
It's an implementation detail for a reference model though. Like
of course.
Recirculating the reference model would not put any imposition or any requirements on an implementation that it has to recirculate.
But the other thing is that if we can have the the application, say that application calls the flow APIs, right, and to do say flow resimulation or the fast pass or the flow insertion, of course, and that one is can be like very nice because it can actually execute the SAR APIs we provide. Because essentially the BNV2 or the behavior model, one of the things that behavior model does is to provide the header files, like SAR header files.
So who's planning to write that application, or is it already written?
So we have the resources allocated for that application.
And what language do you plan to write that application in, out of curiosity?
Oh, C.
So you're thinking of a separate user space application that, for example, we could make a version of -P4 code that says, look up the contract table, on a miss, punt the packet over to this other user space application, and then later that user space application will generate a packet that inject it back into the P4 DPDK data plane and say, here's the right answer, inject this, insert this.
Kind of, but so the idea is that say the packet hits the contract table, right? So just like you said, the contract table. So if it doesn't hit, then execute the rest of the pipeline. So by the end of the pipeline, because the reaches end is just like the the dash CPS pass. By the end of the pipeline, it pumps into the application, and then application will say, okay, I got our result. So this is the flow I need to insert. Then it will call the SAR API, and there will be a flow API, right? So the Flow API will insert internally, will like talk to, for example, use if it's P4 DPDK, then it talks to the DPDK, says, and this is the entry that needs to be inserted.
So and this technique of a separate user space application that calls a SI API to insert a flow, you're thinking of that as a reference model only technique.
Yeah, reference model only. Yes.
Yeah, not a production implementation technique.
Yeah. Not production implementation. Yes.
Okay. Does that answer your question, Chris?
Yeah, that last part really clarified it. This is just an experiment, a science experiment to get the functionality we want with the existing limited software model.
Yeah,
right?
and somewhat for code.
But in terms of production technique, right, why? I mean, that's up to the vendor to figure out how do they want to insert the entry, right? So it cannot, whether it's a production technique or not, that's definitely up to the vendor, right?
Yeah.
Whether they add it in hardware or go through the software, as long as the CPS requirements are met, that's more of a
There's no requirement says, and hey, we have to use like this application to handle CPS fastener. Yeah, this is purely up to the vendors. Yes.
So, which means we could then build test cases to show that it's working, and we'd want APIs to read the flow table as well, right?
Yes.
The only thing which I have the only question I have with this approach is that when you're writing tests, right, the only problem will come is that when you write the test, you send the first packet, but then you don't know that how long to wait before the application will come and program the entry. So before you can send the second packet, maybe we just insert some delay or something in the test case to make sure that, okay, if I wait this much in the test case, the application will program.
It is what we are already
it's
doing
asynchronous,
in the test case. Yes.
Yeah,
we say, okay,
Even
we waited
now,
2 hours. Yeah, we wait 2 hours.
2 hours.
Yeah, we'll have to figure out something because it's asynchronous.
Right.
It's
running on a Raspberry.
Come back, then you're safe.
It's running on a Raspberry Pi.
Okay.
Send the SYNAC and wait for the SYNAC and the application, and then you're probably good.
Yeah. But out of all this, there's another takeaway, and that is the P&A architecture actually adequate to represent or support these kinds of applications well? Or are we already finding workarounds? That's a rhetorical.
One of the main questions, I guess, is, well, so if the P&A implementation on P4 DPDK already does either the clone or the digest message implementation that I'll look into after the meeting, that would support this separate application technique.
No, let me restate it. Without having to play tricks going back up to the CPU, can P&A represent the model where it's all self-contained in the P4 code?
As long as the application the C application that was being described can be implemented by a sequence of, P4 tables that calculates the results in the P4 program, then I believe that you could do the technique what I was describing, which is look up the contract table early, but don't add on miss and look up. Yeah. If it misses, do the long sequence of, however many table lookups you need to figure out what the flow entry should be. Perhaps recirculate the packet if the implementation only allows you to look up the contract table once per pass. And after recirculation, then do the add-on miss lookup in the contract table, now that you know the proper action.
So there may be a way to make it work, but I guess I'll ask you one more time. Does it support it in a natural and seemingly efficient way? Or are we jumping, let's say, having to work extra hard to make it kind of work? It's just, or did the P&A anticipate these kind of use cases, or do we need to, take a look at it? Because I'm sure in vendor implementations, DPUs that have P4, which we know of a few, they can do whatever under the hood and maybe circumvent P&A limitations and do it in the best platform way. But to do it in P4, it seems really awkward. Maybe that needs to be looked at someday, somehow.
Yeah,
I mean, do you have a feeling for that?
Yeah, one of the case I'm also thinking is, say, examples like BFD. So for in that case, say we receive the BFD packages in the HA scenarios, and then we need to respond. So then the P4 pipeline receives the BFD. We need to reply based on what states we are in, those sort of things.
Yeah.
So I feels like even so, no matter what, the at the end of time, the app is kind of needed to handle some stuff.
Yeah, sure. Slower control
Yeah.
plane stuff like BFD and ARP and things like that. They're,
Yes.
you know, an onboard ARM processor or a good CPU can deal with it, but it seems we're kind of used to that. But when you get to something like flow table in real time, a million connections per second, you really don't want to be crossing that CPU boundary.
But Chris,
right?
even for things like fast path and so on, right? Eventually, sooner or later, we will need some kind of application because
Yeah.
I don't know if P4 pipeline or PNA.P4 can support use cases like fast path, right? When you get ICMP packet and based on the ICMP packet, you go and modify the flow entry. So that is something that if we want to simulate in the behavioral model, we will need this application which Riff is describing.
Oh,
It will be very hard to
was-
implement that in PNA.
No, I was trying to agree with that statement. Maybe I didn't state it well. For lots of control plane applications, we're used to punting to the CPU and letting it do its job, right?
Mhm.
That's fine for slow kind of things, like comparatively slow, like ARP and BFD. And BFD doesn't send that many messages per second,
Mhm.
right? But flow tables and, you know, millions of connections per second, you really don't want to cross that CPU boundary. I mean, maybe it's on a system on a chip and it's going to a fast ARM processor. That's, you could say, okay, that's sort of a data plane implementation that's tightly coupled, but you don't want to go up to a control processor, traditional control processor for flow add, right? So if that's the case, then can P4 handle the application we're debating right now in a natural way? I don't know. I'm kind of feeling like it's a bit of a stretch based on what Andy described up some possible solutions. It just feels like it's a little bit hard. But maybe I'm mistaken.
I mean, the looking up the same table twice, once look at the contract table twice, once without the add-on miss feature, and then later
Yeah.
on a miss in the first one, later you do it again with the add-on miss feature. To me, that seems like, I don't know.
That seems okay, huh?
My judgment may be skewed because I am used to living in workaround land in P4, but to me that seems
Yeah.
like
Yeah, that doesn't
within
seem too
within the
bad.
realm of complexity. That's not a big hoop. It's a normal hoop to jump through. I don't know about the
I
ICMP.
guess
I don't know about the ICMP complexity issue being talked about. I'm not aware of the details of that. That might be harder to handle.
does BMV2 let you look up twice a table? Does the backend let you?
If you recirculate, yes.
If you recirculate.
BMV2 you have to recirculate.
And we're not worried about performance in BMV2 anyway. It's super slow to begin with.
Right.
But I wondered if we did this in P4 DPDK and in a manner that Andy suggested without recirculating, but just with a second table lookup, would we get something that's performant and doesn't clog the pipeline with twice the bandwidth?
Even on P4 DPDK, the recirculation might be helpful or necessary. I'm not sure.
Oh,
I
okay.
can find out.
All right. Well, I guess this is one of those in the weeds discussions Christina was alluding to. So I think that answers
yeah,
your question.
I mean, these are always good ones. Yeah.
Yeah. It was a good discussion.
Yeah, definitely. Would it be beneficial? I mean, I try to pop into the P4 open source calls here and there. And those are what, every other Monday, Andy?
The architecture, the PNA discussions, most Mondays except
Mondays,
like
1 o'clock, I think.
we average about most Mondays except once a month when the language design workgroup meetings are held.
Yeah. So I try and pop into those every now and then. So maybe if I pop into one, I can invite you along, Chris.
Well, if it's about something I want to listen in on, I mean, I go to a lot of P4 meetings.
Yeah.
I have to restrict how much time I spend in meetings.
Sure. Well, if we have the questions about if it can even support the applications or whatever. Yeah.
So Riff, based on all this, do you still think you want to do a separate application that programs SI, or just do it inside P4 in the first place?
I still leaning towards have the application. The reason is that one of the reason is that say one of the APIs we actually need to provide is an I'll take one example. Bring your own data plan app. Yeah. So if you, Christina, if you can open the Bring Your Own Dataplane app, then it would be awesome.
Okay.
So yeah. So
one?
in the So in the Bring Your Own Dataplane app, what one of the things we need to do is send, say we have the packet, and the packet lands on the, on the application. Then the application will need something to actually execute and insert the flow table back in. So because with the application, we can actually really nicely access the APIs we generated from the behavior model. So in that case, when say, okay, when people actually use the APIs, we know it works in the way we expect, because all the flows like we generated from this flow table inside of the data plan, we pretty much have a POC that serves as an example or and a test case to say, hey, this API actually works.
Riff,
yeah.
This Bring Your Own Dataplane app,
Mm-hmm.
is this idea intended to be used in a production Dash implementation, that a Dash customer could buy a Dash device, write their own application according to the rules described in this document, and then install that application into the Dash physical device, and then the application would then be running on some embedded CPU or something inside the Dash device and processing every packet that missed in the contract table?
Yes.
And you'd want this application to support millions of packets per second?
Yes.
And if you look at, for example, the Alibaba use case which they presented right about 9 months ago, that was mostly a NAT use case. And in the NAT, when you get the first packet of the flow, you have to pick an open port. And so I think in their use case, which they described, is that the packet does go to a CPU, that is embedded CPU most likely, and the embedded CPU picks up one of the open, ports, because the hardware typically doesn't have this capability to pick one of the, unused ports or something for NAT. So in their use case, which Alibaba described, it was going to CPU. So
yeah, there are also other use cases. Like, for example, like Microsoft, we actually have some private use cases we cannot disclose. So those cases are like mostly say we have a data plan app that we need to run. So yeah, it will be like, this is why like the Bring Your Own Data Plan app say we definitely want to leverage the Dash community, right? All the existing things are already there, like everything provided already there. But there is something additional that needs to run. But you cannot go to the public space. Then what we should do? So this is another thing, like the Bring Your Own Data Plan app actually helps. But in that case, we'll have the application that running in a to handle the the high frequency of the packet, and in that way, like we will need those APIs. Say the really the most basic one is the flow API to be executed to be really works, like proven to be works.
And are you expecting? My personal guess is, I would not be surprised if some Dash device implementers would say, yeah, we'll take such an application, but we'll have to run it on 4 embedded cores, not 1, to keep up with the throughput you want. Have you heard any feedback like that? Because I wouldn't be surprised if one embedded CPU core couldn't keep up with that rate for some application you want to run.
I'm not sure if we can discuss it here, because it is related to like vendors' hardware specs.
I'm just saying, if at least one vendor has said we'll run that on multiple embedded CPU cores, then and you're okay with that, then I'm happy. If no vendors has told you about that and you're assuming it's running on one CPU core, I would worry.
I would ask Christina to handle that. Probably sure be better.
I'm still on VNet to VNet over here, like.
I see. Okay.
I'm just trying to get that to work. Yeah.
Christina, is that okay to answer that question?
Yeah. I'm very open with these guys. Yeah.
Awesome. So so far, I'm not getting any like the feedbacks that there is only one core we can actually use to run those applications. So the throughput should be able to be guaranteed. Yeah.
Right. But for example, if this application that you're bringing your own needs to maintain state across different flows, for example, if it ends up being running in 4 embedded CPU cores, each with separate memory, that there's issues like that could suddenly arise that you can't do everything you want in that application.
Yeah, that's why the bring your own application is just like the application internally it has the it has 4 queues, handles 4 cores, so they need to manage the memories.
Okay. I mean, as long as you're thinking about this running on multiple CPU cores that don't share memory, then you should be better off than if you were assuming one core shared memory.
Yeah. Yes. It has the RSS handling internally. So in the design doc, I have the RSS covered it a bit.
Okay. That's
it has RSS handling, which just use the DPDK APIs.
Okay. Thanks.
Are you guys okay being over by 5 minutes here? Or I did not intend to. Okay, cool. So I was wondering, would it be okay, Marian, if I emailed you about a couple that were waiting on your comments? Would that be okay with you?
Yeah.
If
and there are, by the way, and there are 2 pull requests which are one-liners, just fixes to private link that we discovered during testing.
Oh, really? Did you want me to bring them up here, or?
Yes, sure.
Okay, I'll do it real quick.
I'll just give you the numbers: 500 and 498. 500
here and 498 here. So you need them approved for merge or something?
Yeah.
Okay, cool. All righty. So riff approved, squash and merge. What riff?
Yeah. I already checked that. It's like, it's a really straightforward fix.
Marianne's like, I listened to this whole call just for this
single PR proof.
You could have said something at the beginning, Marianne, and just kidding. Okay.
Also, by the way, Andy, one addition to I think one of the comments is that because I figured like the reason you ask those questions. So let's say there is a hardware that doesn't really support like bring your own dataplane app. So in the side, we actually have a capability model that we can say, okay, for this device, it really doesn't support bring your own dataplane. So that is actually supported. It's just like a capability that a device can support.
Okay, and then customers can make their decision based on that.
Yes.
Okay, thanks.
Yes. So it's not like 100% required. If you don't support it, you are not part of the community. No, that's not. Yes.
Okay, then unless there's anything else for today, guys, I guess I'm going to do the 5-second rule.
I just want to post one quick link and let people know I stumbled off this p4tc.dev site that must be kind of recent, or I just found it, but it updates on the P4TC work underway that I mentioned.
Oh, let's all look at that and talk about it next time. Yeah.
Yeah. So anyway, take a look. Yeah. Well, there's nice paper. There's nice links. There's nice articles about how and why. I'm real excited by it, and I hope it eventually gets upstream to the Linux kernel, because then there'll be a kernel implementation in every Linux, right? Performant with ePPF links. Pretty cool.
Yeah.
Yeah, there is also one for the P4 ePPF, but I remember that one has an issue with I forgot it's the incoming packets or outgoing packets handling. So yeah, I hope this one will be better. Really looking forward to that.
Yeah.
Cool. Okay, well, thanks, guys. As always, in the weeds. I enjoyed it.
Yeah, that answered your first question of the day.
Mm-hmm. Yeah.
Do we need a separate meeting?
Yeah. Have a great rest of the
week. For now,
yes.
Yeah. Thanks all.
Thanks for everything.
Everybody.
Okay.
Good talk.
Thank you.
Thanks, Regina.
Bye.
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 Bye.